So the equation that's up there, I want you guys to go ahead and plug into your calculator in the y equals screen. So this equation right up here. And we're going to answer a few questions about it. So what's the degree of this polynomial?
10.
Now be careful, it's not in factored form, so you shouldn't be adding them up because it's not in factored form.
4.
The highest exponent here is a 4. So anytime it's standard form, you look at the highest exponent. So the degree of the polynomial also tells you how many x-intercepts you could possibly have, or how many roots you should have. So the answer is 4. When we solve this equation for x, we should get 4 answers. Okay. It's possible that one of the answers might be redundant, like you might say x equals 1, x equals 1. You might say it twice. So the answers don't necessarily have to be different, but you should be able to get 4 answers. So next they want us to draw a sketch of the graph. They said to see the whole graph on the calculator, change your window. So hit the window button. So for the x-min to be -10 and the x-max to be +10 like normal is fine. But they said to make the y-min -200 and the y-max +200. And then go ahead and hit graph. Okay, so we're going to go ahead and draw a sketch. All right, so when you look at your graph, does it look like these roots have a multiplicity of 1 or of 2 or of 3?
1.
1. They each have a multiplicity of 1. How do you know it's 1?
Because it goes straight through.
It goes straight through. So that means from the real x-intercepts, we have 1 answer here and the second answer over here. And how many answers were we supposed to get? 4. That means we're missing 2. So the 2 answers that we're missing are going to be complex roots or fake. The other roots or complex. That's why they don't show up on the graph. So the other 2 solutions to that equation are going to have i's in them. They're not going to be real answers. All right, so we're going to go ahead and actually do this problem. When you do this problem and problems like these, it is not important for you to see the entire graph. All you have to see are the x-intercepts. So go ahead and hit your window button. We're going to take that y-min and the y-max and put it back to -10 and +10 like it normally is. So put the window back to normal. And when I have you guys do problems like this, the x-intercepts are always going to be nice numbers, so they will either be whole numbers or they will be nice fractions, like 1/2 or 2/3 or 3/5. They'll be nice fractions. Okay, so go ahead and hit the graph button. What's happening now is you can't see the whole graph, but you can see where it crosses the x-axis. So what do you guys think one of the x-intercepts is?
3.
So 3, yep, I'm going to say x equals 3. And x equals -5. All right, now anytime you have the x-intercepts on here, just to make sure that it is actually at -5 and it's actually at 3, I want you to hit second trace. Second trace, and we're actually going to do number 1 because number 2, you're right, we normally do number 2. But when you try to do left bound and right bound on a graph that is this stretched out, it's really hard to do. So instead, we're going to do number 1, and I'm going to plug in 3. And if I plug in 3 for x, what should I get for y if it's an x-intercept? 0. So I plug in 3 and I get 0. What does that tell me? That was an x-intercept. We did it correctly. I'm going to plug in -5. I get 0. What does that tell me? We got it correctly. Okay, so those are the actual, these are the real roots. And now we're going to do the process to find the complex roots. And what we do is we do synthetic division. All right? So, do you guys want to start with 3 or do you want to start with -5? Start with 3. Okay, so we're going to put 3 in the box. And then we're going to start synthetic division for this problem. So I've got 1, 2, -11, 8, -60. And I'm going to do the process of synthetic division, and for today, all of our remainders are going to be 0. And they're going to be 0 because of the remainder theorem, right? The remainder theorem says if I plug this number in, then the remainder is what I should get, right? And if you plug 3 in, you get 0 for y because this is an x-intercept. So these should always equal 0. So I drop down the 1. 1 times 3 is 3. 2 plus 3 is 5. So 5 times 3 is 15. 4. 4 times 3 is 12. 20. 20 times 3 is 60. And then we get 0. Okay? Then when we're done doing synthetic division with that first x-intercept, we do it again with the other x-intercept. Now, we do not start at the beginning. We take the numbers we just got and we move them down. So 1, 5, 4, 20. And again, this is going to equal 0 because this is an x-intercept I'm plugging in. If I was to plug the x value into the equation, the y coordinate would always be 0. So it's always going to have a remainder of 0 over here. So I drop the 1 down, there's my 1. Yeah, 1 times -5 is -5. That gives me 0. 0 times -5 is 0. That gives me 4. Negative 20. And that gave me 0 like it should, right? Okay. All right, now let's think about how synthetic division works. If this was an x to the 4th, then what's this? Okay, so x to the 3rd, x squared, x, no x, and we're not going to have a remainder. Okay, so that means that this one that we divided was x to the 3rd, so what is this one?
X to the 2nd.
X to the 2nd, 0x, and then 4. And here's what we do at the very end. We take this part that's left over, it's always going to be a quadratic, and we set that quadratic equal to 0. So I'm going to say x squared plus 0x plus 4 equals 0. Do I really need that 0x in there? No. Okay, I'm going to ignore the 0x. Okay. Now, how could I move things around so I'm going to get that x all by itself? Yeah, I'm going to go ahead and minus the 4 over. Now, we already found our real x-intercepts. So that means that what I'm about to solve for has to have an I in it. If I don't get an I in it, I did it wrong. Okay? What do I do next to solve for x? Square root. Now, whenever you square root to solve a problem, what are you supposed to put in front of the square root sign? Plus or minus. Yeah, there's 2 answers there, the positive version and the negative version. We've got the square root of -4. Yeah, so 2, the square root of 4 is 2. Now, it wasn't a 4, it was the square root of -4. So it's imaginary, so it's 2i. So the square root of 4 is 2. We were taking a square root of a negative. That means we have to have an I in our answer. So when we look at this problem, it had a degree of 4, and so that tells us we should have 4 answers. So we have 3, -5, positive 2i, and negative 2i, and that gives us our 4 answers. So 3 and -5 will show up on the graph because they're real. Positive 2i and negative 2i will not show up on the graph because they're imaginary. Tricky?
Not really.
It's not really?
I mean, it's okay. It's just
Kind of interesting. Okay, so how do we start the next problem? We plug it into the calculator. We want to see what our real x-intercepts are. And remember, we don't care how big the graph is. We don't need to see the whole thing. We just need to see where it crosses the x-axis. And what x-intercept are you finding? 3. 1, 2, 3. Okay, it looks like 3. And I'm just going to make sure I got it right. So second trace, option number 1. I'm going to plug in 3 and make sure that I get 0 because it should be an x-intercept. And I did. Now this problem is a little different because how many answers are we expecting to find? We're expecting to find 3 answers. So that means that one of them is real. What's going to happen with the other 2? They're going to be imaginary. All right, so when we do synthetic division this time, are we going to have to do it twice? No. Nope, just once. Just once this time. So 5, negative 17, positive 9, negative 9. What if a problem said it had a degree of 7?
That's too much.
That's a lot of answers, right? That would just mean that you're probably going to do synthetic division a bunch of times. All right, so how should I start it? Bring down the 5. 5 times 3 is 15. Negative 2. Negative 2 times 3 is negative 6. That adds up to be 3. 9, 0. Okay, so if this was x to the third, then what's this right here? X squared. So we've got 5x squared. We got 5x squared minus 2x plus 3. Now, is this one going to be as easy to solve as that other one? No. So what do we have to do to solve it if it's not as easy to solve? We cannot factor it. You factor things when you get real answers. We already know we found all the real answers. This one has to be imaginary. Has to be. We have to do the quadratic formula. Right? So, if you guys remember, it's negative b plus or minus square root of b squared minus 4ac all over 2a. Are you looking for today's assignment? It's on the chair. There's 2 pages. All right, so what is our b value?
negative 2.
Negative 2. So we're going to put positive 2 plus or minus.
Plus or minus 2. 2 squared.
2 squared.
Minus 4. Negative 2 squared.
Negative 2 squared. Minus 4.
5.
Times 5. Times 3. All divided by 2 times 5. Okay. Now we know not to plug this all into the calculator at once because we know for sure this is going to be negative. This is a complex root. That means it's fake. It's definitely not going to show up as a good one. So, yeah, you have to have an imaginary number for this one. So we know if we try to type it in all at once, we're going to get frustrated. So I have 2 plus or minus the square root of negative 56, and this is all being divided by 10. So how do I fix this answer so that it looks correct?
Change the 56 and put an I.
Yeah, change the 56 to positive, put an I in the front. And so we had one answer that was real up here, and then our next answer is 2 plus I root 56 over 10. And 2 minus I root 56 over 10. And did we get all the answers we expected to get? Yes. So degree of 3, we expected to have 3 answers.
So it's just like this incomplete, you're incomplete, so that's your answer.
So that's your answer. So the first step on these problems is you look to see how many answers you think you should get.
Is that a negative I?
Then, yep, we have a negative I there. Then you look to see what your real roots are, and you use those for synthetic division. And then at the very end of synthetic division, you're going to have a quadratic to solve that for sure has an I in it. For sure. No chance it doesn't.